Physics, Chapter 14.2 and 14.3, Flat and Curved Mirrors. This is the current schedule as of today. It may be modified depending on how you do on the quiz, multiple choice quiz tomorrow. Minor change in note-taking during class. You'll be taking notes from the slides. You copy the notes that are in red. You write the notes in blue in your own words, and the words that are in black are for your own information. Cornell Notes is a very common form of note-taking. Lesson outline. Reflection. How do you think that we did with the lessons that were taught by each other last week? Notes are going to be on flat and curved mirrors, and then in class is 14.1 section review, practice 14B, and finally 14C. Homework assignment is to review chapter 14.2 and 14.3 and watch the screencast. You're going to get a 50-question multiple choice quest to see if I need to cover any of the material for the past week. The learning targets for this lesson are: I can apply the law of reflection to flat mirrors, I can describe images formed by flat and curved mirrors, and I can distinguish between real and virtual images. So how did the past week go? Reflection, the turning back of an electromagnetic wave at the surface of a substance. The texture of the surface affects how it reflects light. Diffuse reflections, the light that is reflected from a rough textured surface. Specular reflection, the light reflects from a smooth, shiny surface. You can see on the image that the diffuse reflection scatters the light waves, while the specular reflection, the light waves stay in one solid beam. Angle of incident is the angle between the ray that strikes the surface and the normal to the surface at the point of contact. It's represented by theta. Angle of reflection is the angle formed by the line normal to the surface and the direction in which the reflected ray moves, and it's theta prime. Those two need to be equal, and you'll notice that the normal line is at a 90-degree angle to the mirror. It is possible to see images in a mirror. You can see an object here and an image in the mirror. The flat or plane mirror is the simplest of all mirrors. Light rays bounce off the object in front of the mirror and reflect from the mirror surface. An object reflected is said to be located behind the mirror, although not literally. The object distance is equal to the image distance. Virtual images are not real because they cannot be projected. It's an image that only seems to be there. The only thing flat mirrors form are virtual images, an image formed by light ray that only appear to intersect, can never be displayed on a physical surface, and the distance from the image to the mirror is equal to the distance of the object to the mirror. Objects on the left appear to be on the right. Rays seem to come from behind the flat mirror or the plane mirror. It is virtual as if the rays were coming from behind the mirror. As far as the eye-brain system is concerned, the effect is the same as would occur if the mirror were absent and the chess piece were actually located at the spot labeled virtual image. If light energy doesn't flow from the image is considered virtual. A real image is an image made from real light rays that converge at a real focal point, and that is what makes the image real. It can be projected on a screen because light actually passes through a point where the image appears, and it is always upside down. Ray diagrams are used to represent an image, and you use simple geometry to locate the image formed by the mirror. So reflection, we describe the path of light as a straight line ray. Reflection off a flat surface follows a simple rule. The angle in, or the angle incident, equals the angle out, or the angle of reflection. Angles measured from the surface, normal or perpendicular to the surface. Hall mirror, it's useful to think in terms of images. A mirror only needs to be half as high as you are tall. Your image will be twice as far from you as the mirror. Left-right reversal. Ambulance on a car. Ambulance is actually written backwards so that you can actually see the image in your rear view mirror when you're driving a car. What if the mirror is not flat? Light still follows the same rules, with local surface being normal. Parabolic mirrors have exact focus. They're used in telescopes, backyard satellite dishes, and other items. They form a virtual image. Concave mirrors curve inward, may be a real or virtual image. Convex mirrors curve outward. It reduces images to a virtual image. They're used in store security, rear view mirrors, and an object appears larger or closer than it actually is, or objects are closer than they actually appear in the mirror. Plane mirror, the image is a virtual one. Concave, the focus is real, and it is a real image. Convex mirrors, it is a virtual image. This is the mirror equation. 1 over P plus 1 over Q is equal to 1 over F. The magnification equation is M is equal to H prime over H, which is equal to Q over P. The sign of M, plus or minus, tells you whether it's a virtual or real image. Snell's law of reflection is the relationship between the angles of incident and refraction and the index of refraction of both materials. Finally, review chapter 14.2 and 14.3 and watch the screencasts.